Welcome back to another video. Sorry, I'm having some trouble uploading, so I know this is later than I said it would be, but and I think I'm going to have to chop this up into smaller videos. So I'm going to do the warm-up slide and the note slide, 1 or 2 note slides, and then I'll cut that off, and then I'll do an example slide. Alright? So, here we go. Here's your warm-up. Use the discriminant to decide if this quadratic is prime. So before I even start this problem, I'm going to make note that my answer is either going to be yes or no, right? Whoops. Yes or no. Right? They didn't actually ask me to factor. They asked me to use the discriminant. B squared minus 4ac being negative 79, yes, you have a calculator, squared minus 4 times a times c. And when I did that on my calculator, I got 6,561. And I did not know whether that was a perfect square, so again I used my calculator, and when I took the square root of this, I got an integer. Therefore, this quadratic has rational zeros, and rational zeros will be turned into linear factors that are rational, meaning that no, this polynomial then is not prime. Now, nobody asked me to factor it, but I hope you can see that it's pretty easy to factor this. At first it looked like, oh wow, these are such large integers, but you know, for factoring purposes. But when you have 8 times 10 being 80 and the middle term is 79, hopefully you could see that 8 times negative 10 is negative 80 plus 1x would give me negative 79. But remember, on a quiz, if you had factored this and then said no, this is not prime, you would get a point for no, but you would not get any of the credit for what the problem asked you to do, the work involved, which is use the discriminant. So this problem would have points for the discriminant, points for what the discriminant told you, and therefore how you knew whether you were dealing with a prime or factorable quadratic. This one is asking you to multiply, which again is the inverse operation of factoring, right? Let that sink in for a minute, right? Because multiplying is the inverse operation to dividing, but factoring and dividing are the same thing, right? You have 2 factors, 1, 2, you're multiplying them together, and they are going to equal something. Just like if you had, for instance, 5 times 25, that would equal 125. Therefore, 5 and 25 are factors of 125. So whatever comes in this box, whatever I end up with in this box, these 2 things are factors of it, for no other reason than when I multiplied together, I got that box as a result. So what is that box? I'm going to multiply 1, 2, 3 times, and then I'm going to multiply again, one, 2, 3 times, and I'm going to get 6 terms, right? So I'm going to get x cubed, x times x squared, then minus 5x squared, then plus 25x, then I'm going to get 5x squared, which is positive, and then I'm going to get negative 25x, oops, this had an x with it, didn't it, and then plus 125. So as you can see, the squared and the linear terms drop out, and I get this is equal to x cubed plus 125. That's what's in the box. How do you factor x cubed plus 125? I'll tell you. That's how. 2 factors. How do I know? Because I multiplied them together to get x cubed plus 125. This is called foreshadowing. we are going to be seeing this pattern a lot in today's lesson. But before we go on to today's lesson, first I want to remind you that this is your homework assignment. This is more factoring problems. These problems were ones from the previous lessons, right? This is a quadratic, not. It is an x to the fourth, but it's a trinomial, right? 1, 2, 3, and it looks like it might fit into a quadratic form. Further, since x to the fourth is a perfect square, and 9 is a perfect square, and when I pull this minus down here, and I multiply and double these two, 3x squared, I get negative x squared, negative 6x squared. Therefore, I get x squared minus 3. This problem is one where I suggested that you might use that T substitution technique. Right? If I say x minus 1 is the same as t, and then I look at this problem as 36 minus t squared, I recognize that as the difference of two perfect squares. And then of course I have to put the t stuff back. And I get 6 minus x minus 1 and 6 plus x minus 1. Notice that I didn't bother with my little mini parentheses here because distributing a plus across x minus 1 doesn't change anything. But distributing this minus, right, this is minus t, but that's all of t. So it's minus x and minus negative 1. So this really looks like minus x plus 1, and the second factor is 6 plus x minus 1. Done. Now this one I started to get all excited about because, oh, this is going to be easy. Look, 16x squared is a perfect square, and 9y squared is a perfect square, but there's a sum here. The sum of two perfect squares is prime. More foreshadowing, unless ... This one is prime. Even after I tell you what the unless is, this expression is prime. But there are other sums that look like squares that I think are prime, but there's an unless. And we will get to that later in the lesson. I do want to let you know that you have a quiz on Thursday, and the quiz is all on factoring. You may not have a calculator, and you only have 20 minutes. Hard time. Everybody's going to start and stop at the same time. It's going to be 20 minutes. 10 problems. So how do you study? You pick 10 problems from the homeworks and the video problems that I've done. From that first half sheet to the bookwork from the last video and from this book assignment. And you make sure that you look at problems like number 67. I know number 67 gives people problems sometimes, or any other of the homework questions. You can't leave them until this quiz on Thursday, because what if I put a problem like number 67 on the quiz, or some of the other ones that you couldn't do? So you go through and you make yourself a bunch of quizzes, 10 problems each, and practice them. See if you can get them done in 20 minutes. And then you pick a different 10 and you do that, making sure that you hit them all. Alright, the sum of two perfect squares, I've told you, is prime, and then there's this little asterisk here for later. The difference of two perfect squares is not prime, right? You know that very well. Right? If I have x squared minus y squared, you know that you can factor that into x plus y times x minus y. Well, what if I'm not dealing with squares? What if I'm dealing with higher powers? Right? What if the sum or difference of cubes or fourths or fifths? I am talking about matching powers though. Right? They have to be like powers. So look at this expression. x cubed plus 125. X is obviously cubed, but you know what? So is 125. And this is the problem from the warm-up. I already know what the factors look like. However, let's take a look at this even closer. Recognize x cubed. The cube root of that is x. Can you recognize that 125, that the cube root of that is 5? And then let's look at how that relates to the two factors that we know equal x cubed plus 5 cubed. Notice that the x in the blue box and the 5 in the blue box showed up right here. Notice that the sum was in the first factor as well. And then the signs in the second factor alternated. Start with a plus, alternate to a minus plus. Then notice what was in this box x got squared. The two blue boxes, x and 5, got multiplied together. And the second blue box, 5, got squared. I call this my square, multiply, square pattern for the sum of two perfect cubes. And you know what? That pattern also holds for the difference of two perfect cubes. The only change is the sign. X cubed minus 5 cubed factors this way. All the numbers and letters are the same, except for when you start with a minus, the signs in the second factor are all positive. But notice that my square, multiply, square pattern still holds. Okay? So I recognize the difference of two odd like powers. Since it's a cube, the second factor will always have 3 terms. The first factor is the cube root of x cubed and the cube root of 125. Square the x, multiply the 5 and the x, square the 5. Okay. Alright, I'm going to stop here because, like I said, my last 2 uploads didn't work. Something happened with to corrupt the file. So I'm going to stop this here, and then I will go on to do the examples in the next video. So this is part 1.